Okay, this video is actually 6.4, the Fundamental Theorem of Calculus, and this is going to be part 1. It's going to take us to the bottom of page 50-something, I don't know, 51, bottom of page 51. It says the Fundamental Theorem of Calculus has two parts. These two parts tie together the concept of integration and differentiation and is regarded by some to be the most important computational discovery in the history of mathematics. Be honest. Deep down, you're not only really impressed, but you're filled with anticipation. I know it's hard, but try to contain your excitement. Example 1. In section, and that's actually 6.2, we found an estimate for the distance traveled by finding the area between a velocity function and the x-axis. If v of t is that velocity function that is above the x-axis, so velocity function from 0 to 10, how might we use calculus to define the distance traveled? Well, we already talked about it's the area under the curve, okay, because this is, say, let's see, position something, let's just pretend it's meters, I don't know, meters per second, and then this is seconds. When you multiply meters per second times seconds, you get meters. So we're finding the area under the curve, and in calculus we define area under the curve as the integral from 0 to 10 of v of t dt. So suppose a car's position is given by s of t equals this, where t is time in seconds from 0 to 10. What is the position of the car at 0 seconds? Well, we would just fill in 0. 3 halves, 0 squared, plus 30 times 0, plus 25, and we would get 25. It doesn't have a unit. Let's just pretend it's feet. What is the position of the car at 10 seconds? Well, we would fill in 10, and we would get 475, and let's say feet. What is the change in position of the car from time 0 to time t equals 10? The change in position would be, well, it started out at 25, and now it's at 475, so our distance is 450. And it says, how does this question relate to the previous example? Well, the total distance traveled equates to the change in position. In the previous example, we defined the total distance traveled as the integral from 0 to 10 of velocity. And in the problem above, if we're given position, well, we said it was the position at 10 minus the position at 0, where s, Lindsay just sent me a text and said, yes, we're working out when I leave here, is the antiderivative of velocity. Okay, so here's the Fundamental Theorem of Calculus, part 1. The evaluation part. It says if f is continuous at every point a to b, then the integral from a to b of f of x dx equals big F of b minus big F of a, where f is the antiderivative of f of x. And that last part is actually the toughest part. Below is a different list of antiderivatives you should become familiar with. Now, these should make sense because if you can go forward to take a derivative, you should be able to go backwards to do an integral. Because the power rule, if you had x cubed, okay, to take the derivative of that, the derivative would be 3x squared. Well, how do I go backwards? If I start with 3x squared, how do I get to x cubed? Well, what we did initially was we multiplied that number to the front and we subtracted 1. Well, we're going to multiply that number. We're going to add 1 to the exponent. No, we're not going to multiply anything. We're going to add 1 to the exponent and divide by that number. So, and that gives us x cubed. So it's x to the n plus 1 over n plus 1, and we have to add a plus c because there's a constant. Because if you took the derivative of 3x squared plus 4, and you took the derivative of 3x squared plus 2, this is going to be x 6x, and this will be 6x. Well, the constant, because we don't know what it was, we have to include it. I'm losing my voice, sorry. And then the rule for x to the n when n is negative 1, the integral of 1 over x is natural log because the derivative of natural log is 1 over x. The integral of e to the anything is e to the anything divided by the derivative of anything. Well, if k is a constant, like e to the 3x, the integral of that would be e to the 3x over 3. The integral of sine is going to be negative cosine. With sine and cosine, remember it was sine, cosine, negative cosine, sine where the derivatives go this way, the integrals go this way. So if you took the integral of negative sine, you'd get cosine. If you took the integral of cosine, you'd get sine. The integral of sine, you'd get negative cosine. The integral of negative cosine, you'd get sine. It goes backwards. And you just divide by your constant. Like if you had the integral of sine of 5x, it'd be negative cosine of 5x over 5 plus c. The integral of secant squared is tan. Integral of cosecant squared is negative cotan. And so on. And we actually should already know all these. Okay. So here we have the integral from 0 to 3 of x squared. Well, we add 1 to our exponent and divide by that number. In the notation is we draw a line, we put the 0 on bottom, and we put the 3 on top, and we evaluate it. To evaluate a definite integral, all we do is we fill in the 3, and then we fill in the 0, and we subtract the 2. That ends up being 9 minus 0 is 9. I'm so sorry, I'm losing my voice. There's not too much more to this video, though. On this one, remember that you can split this up and do it in pieces. You just do the integral of 1. The integral of 1 is x, plus the integral of cosine is sine, from pi over 2 to pi. So you're going to get, you fill in the pi, then you fill in the pi over 2. Sine of pi is 0. Sine of pi over 2 is 1. So, minus, plus, negative, positive. Pi minus pi over 2 is pi over 2. 0 plus 1 is 1. Whoops. Did I forget to distribute? I did. Sorry. The integral of 3x wasn't up here in my rules. I'll just tell you. The integral, let's call it 4b. The integral of a number to the x is the number to the x divided by the natural log of the number plus c. So it'll be 3 to the x divided by natural log of 3 from negative 1 to 2. So that's going to be 3 to the second divided by natural log of 3 minus 3 to the negative 1 divided by natural log of 3, which is the same thing as 9 minus a third. So that's 8 and 2/3. Or 3 times 8 is 24, 26 example 6. Oh. It says if this is the derivative, then the integral would just be f of x from 4 to 9. So it's f of 9 minus f of 4. And that's where this video is going to stop. Yep, we're going to stop right there. And the next video we'll pick up with using the evaluation part. And I'm stopping.